Let's now move on and configure the Fiber Channel over Ethernet physical network configuration for our VMware host now. This one is a bit tricky, so I will try to be as detailed as possible. Our VMware server is a UCS C220, which is currently connected to the ACI fabric using a converged network adapter in virtual port channel and leveraging a vCenter VMM domain integration. Such VMM domain is associated to an AEP called servers, which is used in a VPC policy group on leaf 201 and 202 on interface 1.1. This means that this ESX servers VPC is already configured. We can quickly verify that in our APIC, where you can see the ports already configured in VPC mode. Therefore, I will not show you the VPC configuration since you should already know it. We will only focus on enabling FCOE over such VPC, using the same physical adapters and adjusting the existing AEP, switch profiles, and policy groups as needed. Let's get started with our golden questions for our ESX server running FCOE then. The first question is, what do I want to connect to ACI? And the answer is, I want to connect my VMware server using FCOE this time and leveraging its existing VPC connection. As you may know, VMware hosts do not have virtual fiber channel switches nor fiber channel port groups, so our VMM integration will not be used as part of this configuration. What will we use then? Well, first, I will need to create a physical domain to transport FCOE traffic to the host using the required FCOE VLANs. Additionally, I will need a fiber channel domain to map the vSANs from my fiber channel uplinks to the FCOE VLANs. If you remember, we already created a fiber channel domain in part 1 of this chapter, including vSAN 101 and vSAN 201. We can simply reuse that fiber channel domain, as I will show you next. The second question is, do I need VLANs or vSANs? And the answer is pretty obvious at this point. Of course we do. In this case, we will need 3 VLANs in a VLAN pool associated to my physical domain. I will add VLAN 1 and VLANs 101 and 201. VLANs 101 and 201 will be used as Fiber Channel over Ethernet VLANs to transport vSAN 101 and vSAN 201 respectively. But what about VLAN 1, you may be asking? Well, let's take a step back for a second and remember a few FCOE concepts. Hopefully you remember that FCOE relies on FCOE Initialization Protocol, or FIP, which instantiates a virtual fiber channel interface and allows an end device to perform a fabric logging, or floggy. In order for this to happen, FIP needs to be enabled on the CNA adapter. So make sure to do it. And immediately after, it will start the FIP discovery. Why am I explaining all this? Well, because such FIP discovery will be sent on a native VLAN, and unless you add it to your VLAN pool, you will not have FCOE working correctly. Let's quickly verify the CNA settings by logging into our UCS server SIMC. The important thing here is to make sure we have FIP enabled and also LLDP, since DCVX relies on it, and without it, the CNA would not be able to negotiate its capabilities with our ACI fabric. Now, if we click on one of the BINICs for this UCS server, which is currently being used in our VPC connection, you can see that the default VLAN is set to none. Therefore, you would theoretically be able to use any VLAN as long as it is native for FIP discovery purposes. As mentioned before, we will be using VLAN 1 in our case, and we will also provide an MTU that can accommodate FCOE traffic. In this case, I'll go with 9000. Now that we remember how FCOE works, and that we have checked the settings on our UCS server running VMware ESX, we can move on to the vSAN pool part. In our case, I already have vSANs 101 and 201 defined in a vSAN pool, as you may remember, which is associated to my fiber channel domain from the fiber channel configuration. So, I will only need to map the corresponding FCOE VLANs to it, and then, on step 3, I will add both the fiber channel and physical domains to our existing AEP, which is called servers. Make sense? Great. Now, before we start configuring this, you may remember that FCOE relies on lossless Ethernet. Therefore, that means that we will also need to enable priority flow control on a QoS class, setting no drop to a specific class of service. In our case, I will use COS3. We are ready. Let's now go ahead and do this on APIC. First, we will click on Fabric, Access Policies, and we will create a physical domain. Just add a name to it, and we're done with step 1. From this same window, I will now perform step 2 by creating a VLAN pool, which will include VLAN 1 for FIP discovery, and FCOE VLANs 101 and 201. I could do step 3 directly from here, but I will hold it for now so that we can add both the physical domain and the fiber channel domain to our existing server's AEP together. Now, I will move and adjust my fiber channel domain as mentioned before, adding the FCOE VLAN pool I just created, and then mapping each vSAN to its corresponding FCOE VLAN. Good. Now, as part of step 3, I will go to my existing AEP called servers, and I will add both the physical domain and the fiber channel domain I just created. As you may remember, this AEP is already associated to my VPC policy group, which means that we will now be allowing the physical, fiber channel, and VMM domains to flow through the same virtual port channel interface. We are now done with steps 1 through 3. But before we move on, we still have one thing left to do. We need to enable lossless Ethernet. So I will go to the policy section, and under QoS class level 1, I will enable priority flow control, and I will set the no drop cost to 3. Done. Now, moving to question 4, we need to specify which interface we want to configure and how. The good news here is that we already have an interface profile with a VPC policy group, as you may remember. So I will only need to adjust some of its settings. I will just have to create a fiber channel policy for my VPC policy group, indicating the type of fiber channel port we would need, in this case F. I will also enable PFC for this policy group, and last, I will make sure LLDP is enabled since DCVX will require it. And that's it. The rest will stay the same since connectivity is already established and the AEP is already associated to this policy group and interface profile. Which means that we are also done with question 5 since such interface profile is already associated to its corresponding switch profile. Let's go ahead and do this now on APIC. We'll go to our VPC policy group, connecting our ESX server called VPC ESX1, and we will add our fiber channel interface policy. We will add a name to it, we'll leave trunk mode set to off, and we will click submit. Then I will enable priority flow control by adding a name to the policy. And last, I will verify LLDP is enabled on this interface for DCVX to work. Good, we're good to go. As we said, this policy group already has the server's AEP associated, and both interface and switch profiles have already been configured for the current VPC configuration. We're now done. As mentioned before, it is normal to see our fiber channel interfaces still down, and no virtual fiber channel interfaces instantiated yet, since we have not created the corresponding logical network configuration yet. But that will be fixed in Module 3, Chapter 6, when we configure the logical network configuration, creating tenants and EPGs for our vSANs. As a summary, you can integrate fiber channel, FCOE, iSCSI, and many other types of storage networks directly on ACI, consolidating visibility and reducing the number of ports and devices you would otherwise need. Make sure you have the storage protocols license to run native fiber channel and FCOE, and the right switch model supporting unified ports, such as the Nexus 9000 FX series, and you should be good to go.
ACI provides you with a better, simpler, and secure network, any size, anywhere, and on any cloud. If you want to learn more about other common tasks and how ACI radically simplifies network provisioning and operations, please watch the rest of the videos in this series. Thanks for watching.